So just now we have discussed about all the things regarding heat transfer, different modes of transfer of heat, and also coefficient of thermal conductivity. Now in this session we will see about series connection of conductors. So what is the series connection? Already in current LCD we learned about series connection of resistors. So there in series connection, what is the effective resistance? Re is equal to R1 plus R2. The same way let us discuss here the series connection of conductors. For example, this is one conductor, length L1, and another conductor is connected to this one, length L2. In first case what you will see is the area is same, for example. Later on you can take different area. First case we will take same area of cross section both, and length L1 and L2. Okay. Temperature you can take this one as T1 degrees, and here T2 degrees Kelvin. And as we know from the concept of the coefficient of thermal conductivity, the temperature at this end after steady state, attaining steady state, not unsteady, after attaining steady state, the temperature at A end is greater than T2, and also here also you can take one more, theta degrees Kelvin, theta is greater than T2, okay, and here the temperature will be less than this, and this will be the highest temperature. T1 is greater than theta, theta greater than T2, T1 greater than theta greater than T2, or T2 less than theta less than T1 after attaining a steady state. Here the temperature will be more, next here, and last here. Now we will be deriving the effective resistance for this one. So effective resistance, effective value for the coefficient of thermal conductivity. This is the combination of both, you can see. Now the total length will be L1 plus L2. The combination of two conductors in series connection. Because area is same, here also area same, temperature T1 degrees Kelvin, T2 degrees Kelvin. Okay. Now we will apply this formula, that is effective resistance in current LCD R is equal to R1 plus R2. Same thing you can apply here. Okay. So here suppose R thermal 1, and here R thermal 2, and here R thermal effective. So we will apply we will put this formula here, R effective. Okay, R effective, that is R effective thermal is equal to R1 plus R2. Okay, what was the original formula here? What was the original formula? Temperature difference by R thermal is equal to heat current, that is Q by T, rate of flow of heat, which is equal to temperature difference by this thermal, R thermal, that means T1 minus T2 by R thermal. Okay. Now because we are combining, we have to find the effective value. So what is R1 here from this equation? You can see here R1 means, how can you write R1 here? What is R1 here? Delta T, okay, delta T, we will write the same thing here, heat current in this one. You can see in series connection, whatever is flowing heat in this one, same heat will be flowing here, same heat will be flowing here. So heat is constant here, heat is constant. Here in electricity also you can see what will be constant, current is constant and potential difference is varying. So here heat is constant, we will apply this formula here, delta T. For this one, what is delta T? T1, see, T1 minus theta by R1, R thermal 1. Okay, plus for this one, theta minus T2 by R thermal, and this is equal to this one. What is this one? T1 minus T2 by R thermal effective. R thermal effective. Please note down. please note down. Now as we know, what is R thermal actually? What is R? Simply R is equal to L by Ka. L by Ka. So R effective is equal to L. What is the length of the effective one? L1 plus L2 by Ke. Because area is constant, I can take it as area is equal to R1. For this one, how much you can write? L by Ka. That means L1 by K1A plus for this one L2 by K2A. If you take A constant, then A you can cancel it because throughout A is there. Then finally what you will get? L1 plus L2 by K effective is equal to L1 by K1 plus L2 by K2. So finally what is effective coefficient of conductivity when series connected? So in series connection, Ke effective coefficient of conductivity can be taken as L1 plus L2 by L1 plus K1 plus L2 by K2. This is the final formula for when conductors are connected in series. That is L1 plus L2 by L1 by K1 plus L2 by K2. So this is the derived formula in the case of series connection. Okay. Now let us see parallel connection. Let us see the parallel connection. Second case, parallel connection of the conductors will. I'll draw the figure and also will give the equation also. Okay. Let us see the parallel connection. Parallel connection. So in parallel connection, same as in electricity, current electricity, what you have done there, 1 by R is equal to 1 by R1 plus 1 by R2. The same here also, 1 by Re is equal to 1 by R1 plus 1 by R2, R1 plus R1 R2 by R1 plus R2. Okay. So next case is parallel connection. Parallel connection of conductors. That means this is one conductor. A1 cross section, another conductor, you can even take same area also or unequal area. This is A1, A2. Now this is combining now as a single one. So initially the length, whatever length taken here, same length will be because it is parallel connection, length is constant here. Area now it is added up A1 plus A2. If you take unequal area A1 plus A2, and here coefficient of connectivity K1, K2, and here it is Ke. So apply the formula as current electricity. 1 by R effective is equal to 1 by R1 plus 1 by R2. Therefore, you can write as 1 by Re. Re means what? L by Ke, Ka. Okay. What is the area here? The first one, A1 is equal to 1 by R1 again. L by, what is the first one length? L is constant, isn't it? L by Ka, that is K1 into A1 plus 1 by R2, that is L by K2 A2. Because it is reciprocal, it will go to the top. Therefore, Ke A1 by L is equal to K1 A1 by L plus K2 A2 by L. So L you can cancel, you are having on the left hand side, right hand side, and here you can see we want K effective. So K effective is equal to K1 A1 plus K2 A2 by Okay, you can see here 1 by, you are written here. Finally what you got? K1 A1 plus K2 A2 by, and this one, that is it. Here one thing you have forgot here, area is nothing but 2 times. Here area is A1 plus A2, please, not A1, A1 plus A2, because area are combining, isn't it? So effective area will be A1. The final equation what happens? It is A1 plus A2. So this is the equation in the parallel connection of conductors, that is K1 A1 plus K2 A2 by A1 plus A2. Okay.